Okay, so this is 8K, which is solving equations involving algebraic fractions, where we're going to do all the things that we've learned in Chapter 8 regarding factorisation or getting lowest common denominators. So in 1A, per an example, x on 7 plus x on 3 equals 20. I'd like to work with my left-hand side to getting it as a common denominator of 21 equals the right-hand side first, and then I'll do backtracking or inverse operations to get x all by itself. So for this to be all on 21, I need to multiply this by 3 on 3, so that becomes 3x, and I need to multiply this by 7 on 7, so that becomes 7x equals 20. 10x on 21 equals 20. 10x equals 20 times 21, but I can see I've got a common factor here of 10 and 20, so I'm not going to multiply that out. I'm now going to move the 10 over and say x equals 20 times 21 divided by 10. 10 goes into 20 twice. 2 times 21, x equals 42 as being my answer. So first on the left-hand side, I needed to get lowest common denominators to combine those fractions. In question 2, I've got a fraction over 2 and a fraction over 5, so I'd like to get lowest common denominator of 10. And this needs to be multiplied by 5, so that gives me 5x. And this needs to be multiplied by 2, so that gives plus 2x. And I get 7x on 10 equals 7. And again, I'm going to move the 10 across. 7x equals 7 times 10. But now I've recognised a common factor of 7 on both sides. I'm not going to multiply that out to 70. I'm going to write x equals 7 times 10 divided by 7. The 7's cancel. X equals 10 is my answer. And lastly, in 3a, I've got a fraction over 2 and a fraction over 3. I'd like to have a lowest common denominator, which is a fraction over 6. And my right-hand side is still 11. So 3 lots of x minus 1 plus 2 lots of x plus 2 over 6 equals 11. So if I move the 6 over, it's going to be 6 times 11 or 66, and multiply this out. 3x minus 3 plus 2x plus 4. That gives 5x plus 1 equals 66. 5x equals 66 minus 1. 5x equals 65. And x is going to be 65 divided by 5. And x5 goes into that 13 times. So in 8K, we are trying to solve the equation, but we need to use the algebra that we've learned in Chapter 8 to do so.